So we're going to start the fun topic of bearings. Mostly people don't like these, but that's mostly because they don't listen at all. And so if you refuse to actually listen and follow the advice I'm about to give you, things will go badly. For a start, you need to draw these things. So yes, I know you might think it's going to be quicker if you don't draw them, and it will be quicker, but you'll get them wrong, so maybe draw them, okay? The second thing, bearings are measured from a north line, always. So if you're going to understand, and everything is measured backwards because bearings belong to science, but for some reason that I cannot explain to you, we have to teach them in maths. And so the net result is, this is the one little topic of science that we teach you during maths. And so angles are also measured from north, and they're measured clockwise, which is really stupid. So let me pop that in, and you need to make some notes for this. So the first thing you can write in is angles are measured from north, which is obviously there, and you measure them clockwise, which is the wrong way for maths, okay? So we're going to measure from north in that direction clockwise. Okay, so first of all, let's understand what it says over here. It says the bearing of B from A. So A is where we're starting with. Whatever comes after the word from is first, always, okay? So I would start off by putting in A. There's A. Immediately, you draw in a north line. Immediately, every single time, okay? Things will go much better if you do. Then it says the bearing of B from A is 52. Now, these are not constructions, and they don't care if you don't draw it inaccurately, but I would suggest you try and draw the angle reasonably accurately, because otherwise it makes it very hard to visualize. But they're saying from the north angle, you're measuring 52 degrees. So in other words, if we put a protractor sitting over here, so if we plonked a protractor over here, that would be 0 on the protractor, and that would be 52 degrees, right? So from the north line to the line that B is going to be on is 52 degrees, and now that's B over there, right? Now, usually they'd give you some information about how far away B is as well if you were going to have to draw the diagram, but if they didn't, you'd just draw it any old place, and you'd fill in that information as you work it out. Now, notice, if we know that this is 52 degrees over here, then we know how big this angle over here is, because surely they're cointerior. Surely you can see that we have this shape here, right? So we've got a north line and a north line. So these two angles are supplementary. They add up to 180 degrees. So this one over here must be 128. I'm just checking my addition. So that, yeah, that looks right? That one must be 128. If I said to you the bearing from B the bearing of A from B, that means starting at B and going to the line that A is on. That's this angle there. And that is going to be 232 degrees because, of course, the angles round a point add up to 360. So for bearings, you end up using a lot of geometry as well. You're looking for included angles, co-interior angles, you're looking for co-interior angles, you're looking for alternate angles. It's very, very rare to have to use corresponding angles, but alternate angles and co-interior you're using a lot of. What they'll usually do is they'll also give you some other place. So they could say to you the bearing of C from B, and let's make that is 100 degrees, okay? So then from the north line, we have a 100-degree angle here, and then that would be C, right? If you wanted to, you could now work out the bearing of A from C. And that would be starting at the north line, measuring anti-clockwise until you hit there. And they could ask you a bunch of different questions. They're almost certainly going to give you the length of a line. So they could tell you that this line over here was going to be 16 kilometers, okay? So we know the length of this side. This side is 16 kilometers. And we can work out the size of this angle here, because if we know that this is 128 on the outside here, and if we know that that's 100 over here, so then that's 228. So we can now work out the size of this angle here, doing angles around a point. So we've got a side, we've got an angle. We can work out the size of this angle here because that's obviously that's not obviously 90 degrees, but let's assume that C is due east of A. And for the purposes of these questions, you need to know where north and south and east and west are. I used to be told never eat silkworms, right? But you better know where they are. So let's assume that C is due east of A. Then we'd know that this is 90 degrees here, and we could work out that that is going to be 38 degrees. And we have two sides at an angle, which is plenty for our non-right angle triangle rules to work out everything else. Obviously, at the moment, they're not going to give you non-right angle triangles because you can't use them yet. So you would expect your triangles to have right angles inside them. Okay, but a bearing is measured always from the north line. So the first thing you do is put in the north lines, always clockwise. And if it says from C to A, then they're talking about this angle here, right? If it says from A to C, they're talking about this angle here. Okay, that's from A to C. If they say from C to B, you're going from the north line all the way around until you hit the line that B's on. That is the bearing of B from C. Starting at C, so from C. And obviously, if we know that that's 100 degrees here, if this is 100 over here, then this is 80 degrees over there, right? Co-interior angles again. And so I can work out the bearing of B from C, and it must be 280, right? 280 plus 80 is going to be 360. So you're just using a combination of geometry that you've learned before and the right angle triangle trigonometry, combining it with understanding what a bearing is, which just means clockwise from north. So here is an example from your textbook, which I think is quite a nice one. So this is on page 216 of your textbook. And it's an example of the sort of bearings question they might ask you for, right? It says a ship sails 22 kilometers from A on a bearing of 42. So notice there's our north line, and from A, so from starting at A, we have 42 degrees there. And it sails 22 kilometers, so this is nicely filled in on your diagram as well. And then it sails a further 30 kilometers on a bearing at 90 degrees. So again, I would immediately put in a north line, okay, once it gets the 22 kilometers, and then put my bearing in of 90 degrees, right? And then it gets to B. Then it says, what is the distance and bearing of B from A? So from A means starting at A, and they're saying, what is the distance and bearing of B from A? So from A, starting at A, that's the bearing, right? We want that whole angle there. So obviously if we know this little angle there, we can add it to the 42 degrees and we'll have the whole angle, okay? And they want to know what is the distance of B from A. So they want to know what the length of this line is over here, okay? So you can use a variety of things. We have a little right angle triangle here that you can draw in, okay? And we know that we've got 42 degrees, we've got a hypotenuse, and basically probably what we want is the opposite side, which is, I suppose, this one over here, right? So we can work that out, and it says DE is 14.72 kilometers. So we now know that this is 14.72. So if that side is 14.72, then logically if this is a rectangle, which it must be, right? Then this one is going to be the same, because of the right angles, then this one's going to be the same length. So that's 44.72. So now we've got a second right angle triangle. We can work out how big this angle is in our second right angle triangle, because we have got, what have we got? I'm just looking to see what else we've got. Oh yes, we've got AD. So we can work out AD in this triangle over here, either using Pythagoras' theorem or by using cosine. So either one will be fine. So we've got this side over here, which is 16.35, because obviously AD and BF are the same. Once we've got these two sides, we can then use them to work out this angle. There's the angle that's adjacent and opposite, so it's 10. Once we've got that angle, then the whole angle over here is 90 degrees, so we can subtract it. We'll have this angle here, add it to the 42, and so on. So the rest of the example is over here. Please go through it yourself. It is very, very self-explanatory. And And there are more than one way of doing, there's quite a few different ways of doing this. But please check through it and see that it's fine. And then you're going to have the great joy of doing quite a few questions from exercise 5. Now, this textbook is very, very aggressive, which is why we like it, because it asks you very difficult questions. And I have chosen questions that are not going to be easy for you. If you cannot do some of them, I would at the very least expect some sort of diagram and some sort of attempt at each and every question. And please note, if you can't do question 3, it doesn't mean you can't do question 4. So you don't give up and quit. Also, if you look at a question like, one of the questions I'm going to give you is question 16. And it says a chord of length 12 subtends an angle of 8.2 degrees at the center of a circle. Find the radius of a circle. Seriously, draw yourself a circle. Think about what those words mean. There's only one thing that it could look like. There really is. There's only one thing. And then draw yourself a picture and work it out. It says here at the start of this exercise, start by drawing a clear diagram. That's not a hint. That's not like a friendly optional, maybe you want to, maybe you don't. Please draw a diagram. Things will go much, much better. You stand no chance if you don't draw one. And I'm going to consider your homework incomplete if I don't see some sort of diagram to represent the questions on your page. Okay. Please give them a good try. They are difficult because they haven't given the diagram. That, by the way, is not normal. Generally speaking, an IG paper will give the diagram, so usually it's not quite as hard as this. Give them a good try. You should be fine. We'll go through them very thoroughly on Wednesday.